So we had them out at U.S. Steel. We had a bunch of cranes, the number 4 galvanized line, and they could put a hook on the trolley or the hoist where they would pick up big coals. But they did side shear it and all this other kind of stuff, so they ended up with a bunch of scrap metal. And so every once in a while they would come back and they had a big old bin. It was down, I don't know how many floors down, and they'd come in and they'd put a big electromagnet on the crane, and they would come in and they would pick it up and load all the scrap metal on a rail car, and then they'd take it over to the scrap yard and then they'd melt it down to make steel. Well, the problem is every once in a while we'd have something happen, and all the cranes were radio controlled in number 4 galvanized line. So the guy that ran the crane was sitting on the ground with a box on his or her belly running the thing. And every once in a while it's radio controlled and the crane would lose its reset, and all the relays on the crane would drop out. And what would happen to the magnet? And drop its load. So what we used on the magnet, we used what we call a latching relay, which means you energized one coil and it latched. And the only way you could turn it off was to do what? To unlatch it. So if the relay lost its reset, the latching relay would stay what? It would stay latched, and the crane wouldn't drop the load on the magnet. And so that's where we had latching relays out there. We use them a lot of places. We're going to look at it in RS Logics because it's real easy to do, and they've got that. So I can't diagram. It's in chapter 6. I think it's 625, where they have a circuit that's got latching relays on it. So what you do is you have 2 coils, and this is another thing that the guy was talking about that's not exactly true. What did he say? Oh, I'm gonna open one. What was the thing about outputs? The thing he said about outputs is we could only use an output address once. But we see we're using a bit file, but this could actually be a relay file. But when we look right here, this is B3, and it's B30, and then we come down here. Here's another B3, and it's what? B30. So there's some situations where repeating output coils are allowed, and latch and unlatch it's allowed. So how does this work? Well, I'm going to come up here. We're using normally open push button, and I'm going to download this to my simulated PLC, and then I'm going to go to run, and then I'm going to bring up my IO simulator, and here I've got these buttons. Here's 0. I'm going to come, and it's a momentary contact button. I'm going to come up here and let's go to run, Rich. I'm going to come over here and press it, and what happened? It latched. And notice B3, this one down here in the unlatch, it became true at the same time because it's got the same address. So this guy is latched. I can come up here all day long and hit this switch. Once it's latched, it's what? It's latched, right? You understand that? So how am I going to unlatch it? Well, I got to come down here to switch 2, which is controlling the what? The unlatch. And I come up here and it switched 2, and what did it do? It unlatched. So this is what a latching relay latches. Once you latch it, the run can go false, but the output stays what? True. Until you do what? Until you unlatch it. But you got to give them the same address. You can't give the unlatch. Understand what I'm saying? We have a lot of people that do that. They'll go up there and say B01, then they'll 0, and they'll unlatch it with B0. They try to unlatch it with B01, and it don't unlatch it. So it's got to be assigned to what? Same address, and it could be an output. This guy used B3s, but we could use outputs here. The other one they've got, their latching is with switch 1, so they're latching this guy. So I've got all of them latched. How would I unlatch them? Yeah, I'd have to come down and do what? Switch 3 and switch 4. So those are latching relays. And if you look at the PLC diagram, that's what the guy that wrote the, well, I say the guy, it could have been a lady, wrote the programs for the Festo line. When they did that auto section, they did a ton of latching relays. And it's a sequence. They went through a sequence. So they latched this guy, then in the next one, if that was okay, they unlatched that one and latched somebody else, right? You understand that? And it's just a lot easier than trying to use sealing circuits. Are we okay? Okay. The output instruction are true at the same time, and they're false at the same time. They're either both true or both false. So this is one situation where you assign outputs, and of course he's using B3s as outputs. These are antenna cores, but you assign the same twice. You got if you're going to have a latch instruction, you got to have a what somewhere. You got to have an unlatch instruction, because that'll be like having a circuit without a stop button in it, right? So when they turned the magnet on, they latched it, and the only way, once it was on, the only way they could do was what now? Yeah, they unlatched it. Yeah. And then the power failed, the relay was not power failed, they were screwed anyway. But if they lost the reset on the crane, and all your relays popped out when you lost contact with the radio, which was bad. So sometimes they wouldn't charge, the batteries were rechargeable batteries, and sometimes they wouldn't charge them up, or they'd drop them and break the antenna, and they would lose the range, and that'd have the crane going 90 to nothing, and all of a sudden they couldn't do anything with it anymore, because they backed all the brakes off of it. Supposedly, when it lost reset, all the brakes were supposed to engage, but they back all the brakes off so they could run the crane a lot better. If you ever run a crane, especially if it's got a real long hoist on it, to keep the load from swinging, it used to amaze me, because I never could do that. They'd have that crane going back, and that coil would be like this. They'd be going so fast, and they could hit that thing, and that row would go, it'd just stop, because that's what they'd do. They'd hit it, and then they'd jog it back and forth, and they could do that. It was amazing. We had one that was loading a rail car, and he was on one end of the building, and he was loading a rail car on the other end of the building, and you couldn't even see it. And how did you do that? Well, I'm looking at the shadows on the wall down there, and he could load that. He never missed a spot. So I worked on radio control cranes with that just deal. The other thing that we need to look at is we need to look at forcing. So the two labs we want to make sure you do. So whatever lab you're working on, we got certain labs that we're going to require y'all to do, and that's going to be the timer and the counter labs, and then also the force and that. So this other program I've got hooked up to my PLC here. This is, so the force you got to, it's got to be enabled. By the way, enable is enabled, and it's real hard to disable it. In fact, I hadn't figured out how to do it myself. But notice by default when you load in RS500, the force are what? Enabled. Okay. And to force a contact or to force an output, you got to be in the run mode, right? Everybody okay? You got to be online with it too. So you got to be online. The PLC program's got to be online, right? Now, one thing is very, very important. This is on the slides. Number one is that right off the bat, if you work for a company, you need to find out the policy of forcing contacts at that company. Sometimes they don't let you do that. So if you break that rule and you go out there and kill somebody, then it's going to be, your butt in a sling, right? You understand that? So you got to be real careful when you force contacts or when you force outputs. because now you've lost all the safety features that are built into the control, all the decision making that's built into the control. Now, what's nice about it, it allows us to check a program without actually having it hooked up to all of its inputs and all of its outputs, right? You understand that? So we could simulate the inputs without having a single sensor hooked up. So that's what it gives us the ability to do. Forcing outputs is really dangerous because here your outputs are going to drive something. They're going to cause something to happen, right? You understand? It's either going to cause a cylinder to extend or it's going to cause a motor to turn on. So you need to really, really be cognitive for that. So you got to be you got to be in the run mode, and you got to be if on a Siemens PLC, you'll have to switch to monitor. And then right here we got what? The force files. It's over here in our project tree. So let's force an input. And we've already done this a couple times, right? Okay, so when you double click on it, it comes up with all these dots. If it's got a dot up there, it means it's under the control of your input. It's under the control of your program. To be able to simulate an input, you'll come up here and you just double click on it, and then it turns into where you can do things. I got two options. What's the two things I can enter here? 1 or 0. So I'm over here on input 0, and I'm going to hit a 1, and then I'm going to hit enter. And notice it came up, turned red, and said that that was turned on, which means it's not that push button is not pressed or whatever, or that sensor is not true or false. It means I forced that sucker on. Right? That makes sense? And if I want to turn it off, I come up here and enter what? A 0. If I want to get rid of it, I just hit delete. Yeah, I hit delete and then hit enter. Nope, that didn't do it. If you got a bunch of them, so I deleted, I'm going to hit enter and then went back to a dot. Now, if you got a bunch of them that you're forcing, then you can come down here and sorry, I'm not hitting enter. And I don't have inputs down there. Then you can come down here and click on what? Remove all. And that'll, but if you just want to turn off one force, then you just hit delete and then hit enter. Are you okay? Here we're forcing inputs. We can also what? Force outputs. Notice it comes up to be very, very similar. So it's got a bunch of dots up there, which means it's under the control of the program, right? You understand that? If I come up here and select it, I can enter a what? A 1. Now notice output 0 is going to do what? Turn on. And everything that it controls is going to do what? Turn on. Right? Or I can do what? Turn it off. Now you got to understand, so let's I needed to show y'all that too. So if I come over here and let's say I come up here and I force this one right here. Well, I need to force this one or not work. So this is 0, so we're going to force it, right? But what you got to understand, now I can come over here to my input 0 and I can switch it all day long and I have no control of it anymore. Okay, you understand that? Because I've turned it over to software, right, instead of the hardware. So the only way I'm going to get control of it, if I enter a 0 there, right, I can't do anything with the switch anymore, right? You understand that? Or the push button or the sensor. So I've got to, if I want to turn it back on, I just double click on it, highlight it, hit what? Delete, hit enter, and then now the switch is controlling it again. Any questions on that? Are we okay? So that's force. So we looked at latch and unlatch. Any questions on that? Pretty straightforward, right? Pretty easy to understand. and then the force. Now, what's nice about forcing inputs is you can really, you know, if you got lights or you can monitor it, you can actually simulate sensors and stuff without having the sensors actually do what? Kick it up. Or maybe you got a sensor that's not extremely important and it's holding you up, but it's not a critical sensor. You could if it was okay with your company, you could literally override that sensor, right? Kind of like wrapping a piece of aluminum foil around a fuse, right? Okay, now we'll start into the actual chapter we need to get into, which would be chapter 7. 8, yeah, I'm sorry. 7 is long. 7, and these are the last 2 chapters we'll go through. So what does this deal with? All right, how about let's take a 10-minute break before we get into this?